Let's now look at something called the leading coefficient test. So I have just a little example here, this example right up here. Oops, let me grab my highlighter. So let's take a look at this polynomial, and I want to notice something about it. Do you notice that the terms are not in descending order of the powers? They're not in descending order, and so what I'd like to do is to rearrange them. I want to rearrange them so that the highest power is at the front, and then put them in order from there in descending order. Oh, my cat got up on the table, and he knows he's not supposed to do that. Okay. 3x to the fifth plus 4x squared minus 2x plus 8. Now, this right here, because it's the greatest power, is called the leading term. So this is the leading term. And we want the leading term because we are interested in the coefficient. Okay? The leading coefficient of the leading term. All right? So, let me give you some background, and then we're going to take a look at some examples. If I ask you to graph this first picture, okay, this first function here, that's going to be the line, basically a 45-degree line, right? Like that. If I asked you to graph this red one, it would be like that. Okay? If I ask you to graph the y equals x to the third, it would basically be curved, but it would be the same end behavior. I want you to notice, as we go to the right, the graph goes up to the up. It goes up. As we go to the left, the end behavior goes down, down, down. Same thing here. As we go to the right, the height goes up, up, up. As we go to the left on the graph, the height goes down, down, down. Let's take a look at this last one here. This one would just be a little bit flatter, kind of on the middle there, but the end behavior would do the same thing. All right? If you look at these red ones, they're going to do the exact opposite of the black ones. Okay, there's that, and then this one is going to be a little bit flatter, that. In contrast, when I look over here at this right-hand side, this one is going to be, we know that's going to be a parabola opening up. Right? Well, we know that this is going to be a parabola opening down. So, as we look at this, we're probably remembering, oh my gosh, that's a vertical reflection. And we know that that negative to the front of each of these causes that, or the black graph, to reflect downward, right? And so if I know the basic parent, then I know what the reflection is going to look like. So this, by the way, let me get the correct color, this to x to the fourth power is a parabola, but it basically has kind of a flat bottom on it. So that's not a very good one, but that's something like that. And then to the sixth power, it's even flatter. Even though it's not really flat, it never actually levels out. Let me fix this one a little. It still continues to something like that. Okay, so there are those parabolas. It still continues to, like as I go this way, it's going down, down, down until it hits the origin. And then as I continue to go this way, then it begins to go back up. So it's not ever flat down there, but it looks like it if you graph it. Looks like it. So this one is going to be the same thing, but going down. Okay, and this one again, the same thing, but going down. So here's what we can conclude. If the leading term has an odd power, we know that the end behavior is going to be going in the opposite directions. If the leading term has an even power, we know that the end behavior is going to be going off in the same direction. Notice these are the same directions. Okay? So now let's look back up here at this leading coefficient test. The reason that I'm looking at the coefficient is I'm looking at it not to see the number, but to see if it's negative or positive. If it's negative, I'm going to use the red version. If it's positive, I'm going to use the black version. And what do I mean by version? The version for the graph of a particular power. So let's take a look. Let's just kind of put some of this together. Let's take a look at the leading term. There's the leading term. It's already put in the right order. There's the leading term. The coefficient is positive 1. That means that I'm going to be using just the basic parent graph. By the way, none of this matters. Nothing after the leading term matters at all in terms of the end behavior. Okay? So let's just give ourselves a little sketch of this. This is an even power, and so these end behavior, this right here is going to be going up. As x increases, the height goes up. As x decreases, meaning as x goes toward negative infinity, the height also goes up. Here's how we would write this portion. As x approaches infinity, in other words, as we go this way, y approaches, what happens to the height? It's going up, so we say infinity. Let's take a look at this way. As x approaches negative infinity, as x goes to the left, what happens to the height? The height goes up. Okay? So you're going to need to know, most likely, you're going to need to know this version. I think few teachers are going to allow you to just give the arrows as your end behavior. So you can start off with the arrows, but you need to be able to write it the other way. So let's take a look at this next example. Here's my leading term. It's a positive, okay? So I just need to think of what a cubic function does. It does this, okay? There's the end behavior. So I'm going to go ahead and go there. Now, this other stuff in between, all this stuff, means that it might do something different in the middle. I really don't care about the middle. I care about the ends, meaning I care that as x goes to the right, as we go to the right here, what does the height do? It goes to infinity. As x goes to the left, as we approach negative infinity, the height approaches negative infinity, meaning it goes down. So this is our answer in terms of the end behavior. Okay, let's look at two more. Here's our leading term. It's negative, which means that normally the fourth power would do this, but because it's negative, it's going to be one of those that goes like this. All right, so let's take a look at the red and let's write that appropriately. As x approaches infinity, in other words, as we go this way, what happens to the height? Remember, y is the height. The height approaches negative infinity. As x approaches negative infinity, meaning as x goes this way, y approaches negative infinity. Okay, so there's your answer for that one. Again, did I look at these? Not at all. They don't matter one bit. Okay, and the last one. Leading term, coefficient is negative. Normally, a cubic would do this, but because it's negative, it's going to be reflected, and it's going to do this, something like that. All right, so what happens? As x approaches infinity, what's the height do? It's going down. But as x approaches negative infinity, as we go this way, what's the height of the graph doing? Y is approaching infinity, and there you go. All right, there's the end behavior information. I hope this was helpful.